the way I was thinking about this is I want to first give a little bit of an outlook of where the utility industry is when it comes to big data, kind of a little bit of history and a future view. And then Colin will give a little bit of examples of the work that we've done over the last probably 18 months. All right, so one thing, in the context of this conversation is going to be more on the demand side of the utility space. So things like that are customer-facing and programs that are customer-facing in the utility space. Really quick about PG&E. So we are, serving North California. As you can see on the map, it's pretty much all the way from Oregon down to outskirts of LA. About 15 million people that are within the territory. One interesting thing is we have all the climate zones except for tropical. So a very diverse service territory. That's a big challenge when it comes to serving our customers because we have the Silicon Valley and we have the Central Valley. So two very different kinds of customers that we all need to serve, and also two different climate zones. We don't really use air conditioning up here, but you go into the central parts of California and you do have a lot of air conditioning. So all these things kind of make it a very interesting data questions within PG&E and very interesting issues that we are trying to solve. A little bit about the team. So this is kind of your typical analytical structure, and at the bottom, I'm going to start there. So we try to focus on solving problems, so creating actionable solutions for the organization. And kind of at the end of the process, we also want to look at impact tracking. So how does this problem, how is it solved, and then what are we doing in the future to keep improving? In terms of the mission of my team, we're basically providing strategic and quantitative support to all the different programs on the demand side. And these are some of the key themes that are highlighted: energy efficiency, demand response, distributed generation, pricing products, and electric vehicles. So all the different offerings that we have for our customers, and mainly aim to help reduce bills and reduce energy usage. We also started more recently, and this is one of the things I'll talk in just a slide or two. We started working with other parts of the organization on the supply side, so energy procurement and electric operations. And this is, I think, one of the examples where data has been a great tool to break organizational silos. One of the things that data brings to the organization is objectivity. And I think that's been a pretty good success story that we'll also talk about as we go through some of the examples later on. Great. So what I also want to talk about is generally an analytical process and how that maps into the utility space versus some of the other industries, as well as talk about some of the challenges and enablers of this process. I think most of you will kind of understand one way or another, no matter how you look at it, there's a way to think about the progress of analytics. So here I have on the x-axis is the complexity of analytical work that you can do, and then on the y-axis is the value. And just a bit of history. So we were started about 4 years ago as a team by a senior director who had this vision of improving data-driven decisions at the company. And about 3 years ago, the organization wasn't fully integrated when it comes to data. We had one team that was doing kind of reporting, and the other teams that were doing querying of data, and then the final team that would actually do some value-added analytics. So one of the first steps in actually kind of walking along this path of improved analytics was really the data integration, and really putting all the different data teams together, putting all the different data sources together, and creating cool automated reports. I think that was a major milestone that helped kind of remove some of the barriers, as well as free up some resources to do more advanced stuff. So over the next few kind of steps, I'm just showing a few examples of more advanced analytical things like portfolio analysis and design, as well as targeting and segmentation, very kind of typical stuff. What I call, where we are right now in the utility space, is what I call collaborative analytics, where you have different teams across the organization that was historically very siloed, different analytical teams working together to solve some of these kind of cross-functional questions. Where I see the future is really where analytics removes the silos. So it really is inserted deeply into long-term strategy. And drives long-term strategy. And that, I'm hoping, this is 6 to 12 months. If anyone is familiar with the utility industry, it's a pretty slow-moving industry, very risk-averse, so that might be longer or might take shorter. But the idea behind it is that we really try to integrate data into longer-term strategy and some of the really key strategic issues. This slide is really all about challenges and enablers. And this is where I want to kind of have a little bit of an interactive session. So how many of you have hired an analyst or a data scientist or any similar role over the last, let's say, 6 months or 1 year? Okay, we have a few hands. Great. And how many have actually taken like a month to do it? Okay. Oh, great. What about something like 1 to 3 months? Or 6 months plus? Well, one of the things about working in utility is that for data analysts, we're not as interested as our competition here for the talent, which is Google, Facebook, all these other companies that are really that are using data as the core of their business. So it's always been a challenging piece in hiring and retaining analysts, just to highlight one of the things. Another challenge has always been the data silos. So as I talked about them before, but one of the reasons why we have data silos is obviously privacy of data. So I think Teradata speaker earlier talked about PII. So that's one big part where we got to make sure that right people are looking at the right data and we have restricted access there. At the same time, we also have a lot of organizational silos. In terms of how you make decisions. There's a lot of very specific expertise within the utility industry that you have to know, and that's why some of these silos are created. There's always been a kind of historical data access that was an issue, and a few other things. What I want to talk about more is the enablers, so where we are going into the future. One of the big success stories for us was really when we installed a Teradata platform. And this was really for our smart meter interval data. That's a pretty large data set. We have 5 million residential customers, and that basically means hourly intervals, so 24 data points per customer per day for gas, and then same on the electric side. So an exponentially growing database that we really didn't tap up until maybe 2 years ago when we installed a platform, which now helps us really run really quick analytics and has helped us solve some of the issues in the examples. We'll talk about them more, that we previously could not, and we did not have compelling business cases because the data behind it wasn't there. Another part was, we also grew a lot of our analytical capabilities. So SAS, Tableau, things like that have really helped us, focus our analysts to really do more value-added work and less data digging. So that's been a great kind of win. We also, within the organization, we built a strong brand. We're kind of recognized as a team that solves problems, that solves tough problems, that has really good customer service. So that helped us control a little bit of work that we're doing. And now, as I said, I'm really trying to position a team to do a lot more strategic and integrated work. And then I think finally, this is probably applicable to any industry, but very in particular to the utilities is cross-functional expertise. Because for a lot of decisions that you need to make in the utility space, you need experts from different fields, like engineers, policymakers, business folks, customers, and marketing. So all those different skill sets are required for many decisions. And so this is kind of Timotej's view of the industry, and some of the data I used was a little bit obsolete, but so I don't want any representatives of the industries to feel offended where I put them. But if you think about it, there's kind of 3 buckets, the way I see it, in terms of where analytics is. You have industries that are laggard, and I'm calling out utility as one of them. You have industries that compete on analytics, so they're trying to be a little bit better on analytics to get a higher market size or to get better customers. So I gave an example of financial services there. And then you have companies that are in the core competence. So basically analytics and data is at the core of their value proposition. And I think you can recognize the 2 big players that are just in our neighborhood here in Palo Alto that are not specifically called out here. What I really want to highlight here, and this is a little bit of a plug for any students that are looking for jobs, the utility has a lot of potential. We're pretty nascent in terms of where we are when it comes to analytics, but our data is growing exponentially, and there's a lot of really interesting challenges that are coming up in the future. So I think that's something just kind of food for thought. At the same time, there's a lot of integration with some really cool gadgets like electric vehicles or energy storage and batteries. So those are some of the areas where there's a lot of opportunity in the future as well. So with this, I'm going to kind of hand it over to Colin to talk a little bit about examples. We'll try to go fairly quickly through these. But the idea is that we wanted to kind of show an evolution, as you recall. I'll actually just go really quickly back to this slide, and the evolution of how we went from kind of disintegrated to doing some basic data reporting to start, and then how we are trying to integrate more into the strategy. And one more thing I want people to take away from this slide is don't try to run before you walk. Always kind of focus on improving your analytics in a very structured and step-by-step approach. Because we often want to do a lot of really cool analysis and think we can just do this. If we can just do this really cool regression or really cool machine learning algorithm, all our problems will be solved. That's not the case. You have to really take this as a whole and a holistic approach, and do all the right steps to get there. So, Colin?
Maybe 3 or 4 years ago for the utility, all of our reporting and management decisions were made through essentially Excel spreadsheets and PowerPoint slides that were very static. And because of this, most of our work as analysts or reporting teams was really spent just churning out these static reports that were very labor intensive and also weren't very intuitive to interpret. And as we've gotten new tools such as Tableau, that's really enabled us to move away from this very manual process where the end product isn't even that useful, to these highly automated dashboards that show all of our KPIs and also allow us to really manage to insights rather than just figuring out how to read the data. And so the major benefit of this too is there's a virtuous cycle in that because now analysts have more time to spend on interesting things rather than just massaging Excel spreadsheets, we're able to do more value-added work. And so just an even higher level example of this, our energy efficiency portfolio is one of the largest in the country. And we have many products down from light bulbs to TVs to air conditioners that we incentivize more efficient versions of. And all those different technologies have different levels of cost effectiveness and value to customers. And so as we manage our portfolio, we want to make sure that we are promoting those technologies which provide a lot of savings to customers, but maybe aren't quite at the level of potential we would like to see. Anything else you'd like to add on that?
Yeah, what I would also like to add is really the point of doing a lot of these kind of portfolio analysis was that before you visualize data in similar fashion, executives often don't even come up with some of the questions. But as soon as you show them something like this, you get a lot more questions, and that's where some of the more interesting analysis that Colin was referring to comes from, because it's more easier to understand and more easier to really look at the challenges when the data is visualized in the right way.
Mm-hmm. Okay, so next up is targeting, which one, as some of you may know, PG&E over the past 5 or 6 years went from having everyone's meter was read once a month by someone physically walking up to it and writing it down on a piece of paper, or hopefully a PDA or some other electronic form. And so all you would really know about a customer is how much energy they use in a given month, which one data point per month, so the only knowledge you have about their energy use is 12 data points. And then we'll have programs such as a demand response program called Smart AC, where the goal of this is to figure out which customers are most likely to use large amounts of air conditioning, so that we can give them an incentive to allow us to control that device, so that during periods of very high electricity demand, we can throttle down their air conditioner to reduce stress on the grid. And so 3 or 4 years ago, all we could do is do some logistic regression modeling to figure out how likely they were to accept the offer. And then we had some sense of how much energy they used in a monthly basis, which lets us say, here's the likelihood that they might have air conditioning. If you don't use much energy, you probably don't have air conditioning. If you use a lot, it's pretty likely you have air conditioning. But what I'm setting up here is, in this old world, you might have 2 customers that look to be relatively identical. So they both use the same amount of energy, and they're just as likely to sign up for this program. But now that we have such ready access to smart meter data and through Teradata or similar platforms, we're able to analyze this very quickly. We're able to identify that these customers that once looked identical are actually very different. So one gets up in the morning, uses a lot of energy, and then doesn't really do much for the rest of the day. While the other customer, right as they're coming home, early evening, right when the grid is starting to peak, that's when they're throttling up the air conditioner. And now we know, hey, we should not try to market to that one customer who peaks in the morning. We should only focus our resources on that customer with the appropriate load shape. And just to give a sense for the value this really adds, what we found when we did this is 40% of residential customers account for 80% of the resource potential for that potential program. And then just as you move down the Pareto curve, you see how dramatic there are just some customers who just contribute a massive amount of potential value for this program. And so we're able to more specifically tailor our incentives and our efforts to enroll those high-value customers, which we were not really able to do in a meaningful way before. Another example of this, many of you live in California, and especially if you're homeowners, may have been pelted by ads for Home Upgrade California. And what that is essentially a program to incentivize you to do an energy efficiency renovation of your home. And what we've found through that is that program really hasn't done too well, in part because it's tough to communicate the value to customers because it is a pretty major investment for people, something like $10,000 to really replace the insulation in your home, get a better air conditioner, that type of thing. So what we look to do is leverage our weather data and interval data to really figure out which houses really have the worst insulation that we know of. So we really can know who has the most potential benefit from doing this. And what we find through this is this visualization is comparing heating degree days, which is a measure of how the outside air temperature, and how much natural gas you use. And you see that there's some customers where there's almost no relationship between how cold it is and how much natural gas they use. While you have this other group of customers where there's a dramatic relationship and they use up to 8 times as much natural gas on cold days than they do on a normal day. And that's the type of customer where not only are they a good candidate for that program, but you start to think, hey, maybe we can start to give these customers something like a Nest thermostat, which would let them have, rather than having a set point for the thermostat where it perfectly responds to how cold it is, you start to actually adapt to when that customer is home and when they really need to use that energy. Any questions so far? Okay. Mm-hmm.
You incentivized to, I'm trying to figure out what you're incentivized to do here.
Right, so that's maybe a more fundamental thing we should cover. California for the utilities industry is a bit of an odd duck in that the investor-owned utilities are not incentivized to sell more energy. If you go home and turn on your air conditioning, buy a bunch of new refrigerators and stuff, PG&E does not make more money from that. Rather, we have a rate of return that we're allowed to collect based on invested capital, and as electricity sales or gas sales go up or down according to both weather or increased energy efficiency, if that pushes down energy use, we adjust our rates to recoup the difference. But there's very little upside or downside if electricity sales go up or down, and more than that, we're also incentivized through direct shareholder incentives to manage these energy efficiency programs well. So if we do these energy efficiency type programs and manage them in an effective way, our shareholders tend to get a slight windfall as well. And then also pretty important to that is we also want to have a good customer experience and give people control of their energy bills, which is also a major portion. PG&E is a monopoly, but you still want, so we don't necessarily have the same customer retention problems as other industries, but we still need to keep customer satisfaction high. And one of the best ways to do that is to have these tools out there for people to use so that they do have control over their bills.
Yeah, but I want to add, it kind of comes back to California being so progressive in a sense of climate change. And a lot of these programs are ultimately aimed at reducing the climate impacts and reducing energy usage in general. So that's pretty much what my whole team does, is support different ways that we are looking at that issue, whether that's energy efficiency or demand response that Colin talked about, or even distributed generation. We had incentives for folks to install solar on their roofs. Mm-hmm. So it's always kind of aimed to help reduce greenhouse emissions.
Yeah.
Thanks.
Okay, another example, actually we're getting a little short on time, so let's gloss over this one. But we also look at who is stealing electricity. So again, PG&E you're not literally stealing from PG&E if you do this in terms of it hurting our bottom line, but it's another way in which we can reduce costs if we can reduce the amount of people who are tapping into our lines behind the meter. And so we're able to use tools such as Tableau so that we can have these very automated dashboards and do rapid prototyping of these types of solutions, so that rather than having to go through an RFP and get some expensive vendor to come in and give us a revenue assurance platform, we're able to kind of build a business case through this relatively quick analysis.
And just to clarify, these are all fictional names.
Yeah.
You're going to see them throughout we have to be very careful about customer data privacy. So throughout the presentation, you'll see some of these fictional names, and none of this is actually real data in the background. This is just an illustrative example.
Okay, and then lastly, start to get into how we're trying to go beyond just helping one program or focusing on one effort, and really integrate some of these programs into the broader PG&E business. And so one really great example of that is what we're calling targeted demand-side management for electrical reliability. And clearly these are fake names, but what the general goal is, every year we spend millions of dollars on upgrading our electrical system. And some of those upgrades are very necessary, but the reason why they have to be done is because there is some increased electricity demand on a local level. And so if we can use demand-side programs to reduce electricity demand either temporarily or permanently, we're able to defer some of these projects, which results in a pretty real savings. And it just gives our electrical planners another tool to use our budgets more wisely and really have all of these programs be more cost effective.
And I just want to highlight here, I know we're running short on time, but about 3 or 4 years ago, we tried to make a similar argument, but we did not have all the great data that Colin's going to show in the next slide. And basically, our electrical engineers were basically saying, no, we are not convinced. Now with data that we're going to show in a bit, we can actually give them real tangible results and impacts that we're estimating based on facts, not based on subject matter expertise. And as a result, we now have a few pilots that are running in our service territory. So that's another one of those examples where data has really made an impact and made a change.
Yeah, so just an idea of what smart meters really let us do in this context. This is the old view where we have a single sensor up at the substation, so there's big yards full of electrical equipment you'll see around, and what the load is on that piece of infrastructure. And you can see that clearly these two pieces of infrastructure have very different loads behind them, but you don't really have a sense for what is driving that or what customers are actually driving that load shape. And what we're now able to do through smart meter data is instead of having, it's not working, oh, there we go. Instead of only having one sensor on this feeder, we'll have 5,000 or so for every single customer that's attached to that. And so we're able to see which customers actually contribute the most to the need for these upgrades, and that we're then able to really go out to those customers, have individualized plans for them for how they can reduce their energy use, which lets us very, very effectively reduce the need for these infrastructure upgrades, and also use our resources more wisely. Okay, and with that, any questions you have or?